Yeah, hello all, welcome back. So in this today's session, we'll see how to design the reset set latch by using only NAND gate representation. Right now, if you observe here, so here onwards, whatever the circuit we are designing, so everything we are going to design by using of the NAND logic gate or NOR logic gate. So why we used to perform circuit by using the NAND as well as the NOR logic gate means those are the universal logic gate. It means that if you are designing all the circuit components by using either NAND gate or NOR gate, the time delays will be reduced, right? That's the reason we used to go for the NAND or NOR representation. You can design by using of the basic logic gates also. For this demonstration purpose, I'm going to explain by using of the NAND gates only, right? So what is the meaning of one point to remember is, so latch is the asynchronous sequential circuit. It means that it don't require any clock signal, right? So what is the meaning of R is, R means reset, right? So what is the meaning of reset? The general meaning is that whenever the reset is activated, remember the output should be 0. Reset means whatever the output value will be having, that output value should be 0. It means that when reset is set to be activated, means when reset equal to 1, the output we should get the 0. Remember, this is the important point. Once it is done, what is the meaning of S? S meaning is nothing but the set value. So set means, right? So set means if set is activated means if set equal to 1, then what should be your output value, right? So reset means whatever the output value, that should be 0. Here S is activated, nothing but set is activated means output should be always 1. Remember, simple point is that if R is activated means R equal to 1 means output should be 0. Reset means output should be 0. Set means output should be 1, right? These 2 points you have to remember. Now how many inputs terminal we have? 2 input terminal. One is called as the R, another one is called as the S, right? So now first we will try to design the basic memory element by using of the latch operation with the help of the NAND logic circuit diagram. So here what is the meaning of R is reset, what is the meaning of S is set, right? So what is the objective or agenda of the today's topic is that, so first we are going to design the memory device by using of the asynchronous device, nothing but the latch operation. As we know that latch does not require any clock signal, right, in order to control the memory element operation. Once it is diagram, right, as I told that we are going to design the memory basic building block of the memory element, right? So first we will see that the what is the block diagram representation of the reset set latch operation. Once it is done, so with the help of what we are going to design, with the help of the NAND gate representation, right? So first we will understand the what is the truth table operation of the NAND gate representation. Once it is done, we will implement the latch, right, for reset set latch, right? So for that we will try to design the logic circuit diagram. Once it is done, we will draw the truth table representation of particular reset set latch. Then we will see the what is the operation of the RS latch, right? So these are the things which you are going to understand in this today's lecture, right? So first let me what I'll do is that first let me draw the block diagram of the reset set latch, right? So block diagram means, so if you observe here how many inputs we have, 2 inputs, right? So first what is the meaning of, we are going to draw the block diagram representation, right? So block diagram representation means something like this, right? So how many inputs we have? 2 inputs. What is that? One is called as the reset, or you can call it as the R value. Another one is the set, you can call as the set, right? So this is the RS latch, right? So now if you see that if you take any memory elements, we may have the 2 outputs, right? So one is the normal output, let me take Qn. Another one is the complemented output Qn bar. So what is the meaning of this one is, here we need to understand, right? Here we have the 2 inputs. Based on the memory circuit design, we will be getting the 2 output value. One is said to be normal output value, another one is said to be complemented output value. So it means A means normal variable, A bar means complemented output value. So what is the meaning of this one is, suppose here if you are passing some input value, R value, S value, suppose if you are getting the value equal to 1, something, just for example, if this output equal to 1, then Qn bar value should be 0. then only it is called as the valid representation. It means that it will produce a two output. One is the normal output, another one is the complement output, right? So if it is producing the 1, obviously it should be 0, or if qn value equal to 0, qn value should be 1, then only it is valid. Suppose in some cases you will be finding something like this: if qn equal to 1, you might be finding qn bar also 1, or one more possibility is if qn equal to 0, you might be finding qn bar also 0. So these are called as the invalid conditions. Why it is called as the invalid condition means qn should be always complemented to the qn bar. If output both are the same, nothing but qn bar same value, either 0 0 or 1 1, these are called as the invalid conditions or indeterminate conditions. Remember that. So we have the two outputs, one is the normal output, another one is the complemented output. It always complement to one to another, then only it is called as the valid statement. If both are producing the same outputs, then it is called as the invalid output. This point you have to remember. Reason is that when you are drawing the truth table for the RS latch after performing the circuit operation, then these kind of outputs you will be expected. So based on that we can able to find out whether these statements are valid or invalid statements, right? So what is the meaning of our reset? S means set. When R is activated means that R equal to 1, output set value will be always 0. Reset means output should be 0. What is the meaning of S? S meaning is the set. When S equal to 1, it means that set is activated. What should be the output value? Set means whatever the current state, output value should be 1, right? So then it will produce the two kind of output. One is the normal output, another one is the complement output. If it is complement one to another, then it is a valid condition. It means that we can able to store the some value into the memory element, right? So if it is producing the same value, then it is called as the invalid or indeterminate circuit. These 2 points you have to remember, right? Once block diagram is representation is completed, then what is the next step as per our objective is that first we will see the what is the truth table of the NAND gate representation. Why? Because NAND gate representation means we are trying to implement the logic circuit diagram by using of the NAND gate, right? So for that reason I am going to consider the truth table for the NAND logic gate representations, right? So I am going to take the two inputs values, right? So these are my inputs. So output value, let it be y. So 0 0 0 1 1 0 1 1 are the input values. Let me take what is the output for the AND gate means here we will be having the 1, remaining all cases you will be 0, right? So in case of NAND gate, what is the output value? 1 1 1. So it is just opposite of the AND gate operation. So right, so this is the NAND gate logic, right? Now here we have the one more important point to be remember is that suppose for example let me take the NAND gate operation, right? Suppose if I first input value is 1, second input value is 1, so we can able to decide what is the output value if both inputs are 1 1 according to the AND gate or NAND gate, whatever it may be. If you take something NAND gate, so what is the output value? Both the inputs are 1 1, output equal to 0, right? If something input equal to both the input are equal to 0, output equal to 1, something like that we can decide. When you have the two inputs value, based on that you can able to find out the output value. But in case of our design by using of the NAND RS latch, you will be finding something like this. You will be having the NAND logic diagram, but here you might be knowing this value or this value you might not be knowing. And what is the meaning of this one value, right? I'll be able to know that what is the first terminal value. I don't know what is the second terminal value. It means that either it might be 0 or it might be 1, right? So even though I don't know what is the second input terminal, but I should be able to guess the what is the output value. Guess means in terms of the correct output value. See, if this condition is occur, if I ask you to write, so if my one input is 0, I don't know second input terminal value. If I am asking you to find out what is the output value, you cannot able to find out, right? So as per our circuit design, so whatever we have learned so far, if we know the two inputs value, then only we are going to find out the output value. If one input terminal value is known, another input terminal value is unknown, we don't know how to find out the output, right? So if you want to find out if one terminal is known, another terminal is unknown, then if you just here we have the logic in this truth table. If you understand this logic in this truth table, then you can able to find out the output. If one input is known, another input is unknown also, we can able to find out the what is the expected output, right? So for that reason we are going to design this NAND gate truth table operation, right? See, what is the logic you have to understand here is that, suppose see that, so what is that, this value is right 0, right? Then one more here value is a 0, right? Either you can consider this 0 or this 0. Here one more value is 0, right? So from this what you have to understand is, first we will concentration on the output equal to 1, right? So if we see this input value 0 0 0, right? So what is happening means, right? So just observe here, if any one of the input, right? So if any one of the input equal to 0, then what is the output we are getting? Output equal to, right? So output equal to 1. If you remember this logic, then if you don't know second terminal value also, we can able to find out the output value, right? If you see that here one input terminal value is 0, what is output value? 1, again 0 1, again 0, right? So we cannot able to take the 1 because here we have the two ones, right? So if any one of the input terminal value equal to 1, we cannot able to decide the output. Why means, if the second terminal also 1 means this output 0. Here if it is 1 means output equal to 1. So what I mean to say is that, so according to this representation, when any one of the input equal to 0, directly you can decide the output equal to 1, right? So if you remember this rule, then the remaining steps will be easy for us to understand, right? So see that if any one of the input equal to 0, then it is producing the output 1. What is the meaning of this one is, as per the NAND gate representation, if one input is 0, you don't know second input terminal, what is the output? See, if any one of the input equal to 0, without knowing the second terminal value, we can decide the output. So what is the output value? The output value is the 1, because it is generating the output value equal to 1. So for that you need to remember this logic. If any one of the input equal to 0, without requirement of the second input value, we can decide the output value as the 1. Now you might be having the doubt, if any one of the input terminal value equal to 1, then can I able to find out the output or not? For example, let us we check, right? So what is the input value? This one 1. So what is this value? Unknown value, right? Unknown value means what is the possibility? Either it may be 0 or 1, right? So for the first time we will consider to take the input value equal to 0, right? So we will consider the 0. So 1 0 means what is the output according to the truth table? 1 0 means 1. So this is fine, okay. Next, what is the next possibility? This terminal might be, this means second terminal might be 1 also, right? So instead of 0, if you are considering 1, what is the output? 1 1 means output equal to 0. C means if the second terminal is different value, we are getting the output 1. If the second terminal value is some other value 1, we are getting the different. It means that for different input of the second terminal, we are getting the different output. It means that we cannot able to find out if the one input is 1, if we don't know second input terminal value, we cannot able to decide the output operation. Now we will see the same thing for the single. If single input equal to 0, if you don't know what is this terminal value, we will see, right, whether here we are getting the same output value or not. It means that if you are getting the same output value, then it means that without knowing the second terminal value, we can able to decide the output value. That is the meaning of that one, right? So what is the second terminal value? Either it may be 0 or 1, right? First let me take the 0, right? It means that if I take the 0 assumption, so 0 0 means what is the output value according to the truth table? 0 0 means 1, okay, fine. So what is the assumption of this one? The next possibility will be 1, right? So if I take 1, so what is the output of 0 1? So 0 1, what is the output of 1? 0 1 means 1. See, either the second terminal value it may be 0 or it may be 1, we are getting the same output. So from this you need to understand, if you don't know second terminal value also, it means that either it may be 0 or it may be 1, directly we can decide the output as the 1. But in case of the first input is 1, if we don't know second input terminal, we are getting the different output. It means that by using the single terminal, we cannot able to find out the output value. But in case if any one of the input equal to 0, according to the NAND gate truth table, if we don't know second input terminal value also, we can find out the output. Why? Because whatever the possibility of the second terminal, either it may be 0 or 1, you will be getting the same output only, right? So if you remember this one, what is the concept? If any one of the input equal to 0, without knowing the second terminal value also, we can decide the output equal to 1. right? If you remember this one, the next procedure will be much easier, right? So what is the steps we have completed so far? We have completed the block diagram representation of resets and set. Once it is done, we have drawn the truth table of the NAND gate representation. So in case of if we know only single input, how to find out the output value by using this truth table, by using this logic we have completed, right? Now what is the next step we have to do is we need to try to draw the logic circuit diagram for the right RS latch, right? So for example, if you see here how many inputs we have, two inputs, right? One is for reset, another one is for the set. So for that what I'm going to do means two input means I'm going to consider the two NAND gate representation. So this is one for the R, this is one for the S, right? So this is for reset, this is for something like set. Now if you observe here, I have taken something like this, right? Now it is try to understand, just try to pause the video, then try to find out the solution, whether it is combinational logic circuit or sequential logic circuit. Suppose if you take this one, try to identify whether it is combinational logic circuit or sequential logic circuit, right? What is the answer? The answer is that this is the combinational logic circuit. Why it is the combinational logic circuit? Because the output is completely depends upon the input value. Now how we can make it as a sequential logic circuit means, the simple thing is that if you understand the block diagram of the combinational logic circuit, we may have the one or more inputs, that outputs are which are we are going to store into the memory element. So what is the meaning of this one is, if you are considering the simple AND gate representation, so right, simple AND gate representation, so it is going to give the input, it is going to generate the output, right? This somehow here we will be having the memory element operation, right? Here we will be having the memory element operation, right? So this, if you are giving the input to this one, then this is what we call as the sequential logic circuit, right? Try to understand, if somehow the output is connected to the input, then it is called as the sequential logic circuit. Why if output is connected to the input, then it is called as the sequential logic circuit? The meaning is that sequential logic circuit is the combination of the combinational logic circuit, another one is the memory element, nothing but the feedback path, right? So here this output we are storing, then we are giving to the input, right? So that's why it is the sequential logic circuit. Now as per the design, we have the reset and set, so we have considered the two NAND gates, that's okay. Now if you observe here, this is the combinational logic circuit, this is also combinational logic circuit, because the output completely depends upon the input value. Now what is the thing that we have to do is, this is what latch is nothing but the sequential circuit, right? So sequential circuit means somehow output should be connected to the input, right? Now here what the design changes we have done, so that we can make it as the sequential logic circuit. So let's try to understand. As of now this is only combinational logic circuit, which we need to make as the sequential logic circuit. Then one more important condition, that remember that when R is activated, reset is activated means output should be always 0. When set is activated, output always should be 1. These two conditions should be matched, right? So like that we need to connect the output to the input, right? Now if you understand here, so this output if I connect it to somehow here, then it is called as a sequential logic circuit, right? If this output we are connected to this one, this is called as the sequential logic circuit, right? But here my requirement is that somehow I need to attach the first logic gate with the second logic gate. Then one more condition to be occur is that when R equal to 1, output should be 0. When S equal to 1, output should be 1. So for that, how we have to design the circuit is something like this. Now if you see that this is terminal for reset, this is the terminal for the set. So what is the terminal pending? So this one terminal is pending, this one terminal is pending. Now how I am going to do is that, right, this terminal I am going to attach with this second logic gate, right? So this terminal I am going to attach with the first logic gate. So this is what is the output, expected output, Qn as well as the Qn bar, right? So Qn, then one more output is the Qn bar, right? Now see that we have the combinational logic circuit, along with we have somehow output is connected to the input, so it is called as the sequential logic circuit. The first step is that two input means we are considering the two NAND gate representation, but if you look at that, those are the combinational logic circuit. In order to make those, we need to connect the output to the input. If you connect something like cross couple, right, so that it will become the sequential logic circuit. then it will also obey this condition. When r equal to 1, output equal to 0, when s equal to 1, output equal to 1, right? So otherwise if you are connecting something like this, you will not get this condition. You will be not connected with the one logic gate with the another logic gate. For that reason we are going to perform this, right? So like that we are going to connect one to another, right? So one circuit design is completed. So we have the two inputs, two outputs. Remember these conditions, these are the important. Once it is done, we will draw the truth table operation. So this is the truth table representation. So how many inputs we have? One is R, another one is the S, two inputs. What are the expected output? One is the Qn, another one is the complemented output is nothing but the Qn bar. So first we will try to write the input possibilities. It means either 0 0, 0 1, 1 0, 1 1 values, right? Now what we will do is, right, so we will pass the values. So first instead of passing the 0 0, right, so first instead of passing the 0 0, right, so first we will try to pass the input value 0 1, then we will try to find out the what is the Qn output as well as the Qn bar output value, right? If you can able to find out the answer, then designing of the RS latch circuit is completed anyway. Now we are going to draw the truth table functionality, right? So first we will consider the second combination. What is the R value? 0. What is the S value? 1. It means that I am taking the R value 0, S value equal to 1. Right, so I am taking the R value equal to 0, S value equal to 1. Now if you understand here, as we discussed earlier, right, so you have to remember this truth table logic, right? What is that logic? If any one of the input is 0, if you don't know second input terminal also, we can able to decide the output equal to 1. It means that if any one of the input equal to 0, without knowing the second terminal, we can decide the output equal to 1, right? So why we have understand this concept is, right, why we have written this one is, now you come to here. So this is the NAND gate, right? So let it be this is the first NAND gate, let it be this is the second NAND gate. So if you understand here, for first NAND gate, how many input terminal is there? One is R is there, another one this input terminal is there, right? After passing these two input only, I will be able to find out the what is the output of Qn, right? Now here what is the condition we have? I know that first input value equal to 0, but I don't know what is the second input terminal value. Even though if I don't know second input terminal value, I need to find out the what is the corresponding output value, right? If you know two inputs, that is the easy way to find out the output. But in this case, if one input is known, another input is unknown, we cannot able to find out. So how to find out in this situation also means you have to remember this logic operation, right? What is that logic? If any one of the input equal to 0, it means that if any one of the input equal to 0, even if you don't know second terminal value, either it may be 0 1, directly you can decide the output equal to 1, right? So from this logic you come to here. So for which logic gate we can able to find out? This is the first logic gate, right? First input is 0, second input is unknown. For the second logic gate, the first S value is 1, this terminal we don't know value. Now try to understand for which logic gate we can able to find the output, for first logic gate or second logic gate, right? What is the logic? If any one of the input equal to 0, output equal to 1, right? So see that here first input equal to 0, right? So what is the meaning of this one? If it is known or unknown, no problem, directly we can decide the output as the 1. Why? If it is 0 also you will be getting the output 1, if it is 1 also you will be getting the output equal to 1, right? So it means that for first logic gate, if one input terminal is 0, even though if we don't know second terminal, we can decide the output equal to 1. But come to second logic gate, if one of the input is 1, if we don't know second input terminal value, we cannot able to decide the output value. The reason is that if first input terminal value is 1, there should be mandatory you should know the second input terminal value also, right? So for that reason we have explained this logic, right? Now for which logic gate we can directly find out the output without knowing the second terminal value? Which logic gate? Logic gate 1 or logic gate 2? The answer is logic gate 1, right? So for this reason, so see that if one of the input equal to 0, what is the output value? Output value equal to 1, right? So for this Qn terminal we have obtained the output as the 1. So somehow I need to find out the output for Qn bar also, right? But what is the problem here? The second terminal is mandatory. If any one of the input equal to 1, the second input terminal is the mandatory. But how to get this one? So at the initial case we don't know this value. Now this value is known. How it is known value means, see that what is the qn value? 1, right? This 1 is connected to here, right? It means that the same value will be passed through this loop, right? It means that here we will be getting the value equal to 1. So what I mean to say is the current output value is the 1. So the moment the same value will come to here, right, the same value will goes to here. So what is this value now? This value is nothing but 1. Now how many values we know? 2 values, right? What is the meaning of 1 1? According to the truth table, 1 1 equal to 0, right? Now what is the qn value we got for this condition? 1 0, right? Now I told that earlier when s is activated means s equal to 1 means what should be the output value? 1, right? So now see that this is r value, this is s value. For this condition which is activated, so 1 means activated, which is activated? S is activated. S is activated means what should be the output value? 1. This is always complement value. If it is 1, it should be 0, then only it is valid condition, right? So when s equal to 1, output should be 1. So for example, if we consider this condition, what is this condition? When r equal to 1, what should be the output value? When r equal to 1 means reset equal to 1 means output value should be 0. It means that normal output should be 0, complemented output should be 1, right? So we will see that practically by passing this value to the logic circuit diagram, then we will see how to find out the answer for this one. So this time we will consider the r value equal to 1, s value equal to 0, right? Now try to guess for which logic gate we can able to find the output directly without knowing the second terminal value. First logic gate or second logic gate? First logic gate or second logic gate? The answer is a second logic gate. Second logic gate means without knowing the second terminal also we can find the output value. It means that if any one of the input equal to 0, without knowing the second terminal value we can decide the output as the 1, right? Now so here one of the input is 1, here we don't know with this value, right? As we explained here, when one of the input equal to 1, the second terminal is the mandatory. But how to get the second terminal value? The simple thing, what is the current output value? 1, right? The same value will pass to here. At the initial point of time you don't know, now we know this value. What is that value? 1. Now this input is 1, this input is 1. 1 1 means what is the output value here? As per the truth table, 1 1 means 0. Now see that if it is 0, it is 1 means it is valid state, right? Both are the complemented output means valid state. Now what is the qn value we got? Qn value equal to 0, qn bar value equal to 1. Now if you observe here, which one is activated? R is activated. R is activated means what should be the output value? 0. Just is the complement of this output, that's it, right? Nothing to remember. Now we'll consider the one more condition. Let it be this time we'll consider the 0 0 and we'll see what will be the happen. So this 0 0, what is the R value? 0. What is the S value? 0. Now try to pause the video and try to find out the answer. For which logic gate we can able to find the output directly? Try to understand. For first logic gate or second logic gate, as we said, if any one of the input equal to 0, we don't require the second input terminal. Directly we can decide the output equal to 1. It means that if you observe here, for the logic gate 1 as well as the logic gate 2, directly we can able to find the output, right? So what is the meaning of this one is, here also one input is 0, we don't know another input terminal value. Here also one input is 0, we don't know another input terminal value. As per this logic, directly we can able to find the output value, right? So if one of the input is 0, what is the output value? Directly we can decide as the 1. Here also, if one of the input equal to 0, what is the output value? 1. Or if you want to, you can pass this value, right? Current output is 1, right? This value passed to here, then what will be happen? According to the truth table, 1 0 means also you will be getting the same output 1. Now you here important thing is that now we try to find the answer. It is valid or invalid, right? So it is invalid. Why it is invalid means one output should be always complement to the another output. So these are the valid conditions, valid. So if you are getting the q and qn bar both are same, these are called as the invalid condition, right? So this is what we called as the invalid condition. So what is this condition we call? S is activated, right? So S is activated means we called as the set condition. So if here what is this value? R is activated. R is activated means we call it as the reset condition. Reset means output 0, set means output equal to 1. Just remember that these are the complement to the qn value, that's one, right? So what is the final input value? It is leftover 1 1 is the leftover value. For that we need to find out the output combination. So just I am taking the R equal to 1, S equal to 1. Now pause the video and try to find out for which logic gate directly we can able to find the output. For first logic gate or second logic gate? Yes, the answer is that we cannot able to find the output for the either logic gate 1 or logic gate 2. The reason is that if one of the input terminal equal to 0, without knowing the second terminal we can find the output. But if one of the input terminal equal to 1, without knowing the second input terminal also, we cannot able to find out the output. In earlier case what we have done is, so either we know this value is 0 or this value is 0, so that we can able to find out the any one of the output. That output we are giving the feedback to either this one or from here to here, so that we can able to find out the second terminal output also. But here the cases is that nowhere we are getting the 0. It means that both cases are 1 means directly we cannot able to find out the output value. This is something like tricky. So for that how to we need to find out means, right? So what is the meaning of this one is, if one input is 1, this terminal is mandatory, right? If another input is 1, this terminal is mandate for second logic gate, right? Now here, right, here important point to be remember is that the second input terminal value is mandatory. Either it may be 0 or it will 1. Without knowing this, there is no way to find out the output Qn as well as the Qn bar, right? So this is the something different from the what we have solved in the previous class, right? Now how to solve this problem? Anyway we don't get the second terminal value here, right? Then how to find out the output? If it is 0, that's okay. If it is 1, then how to find out? So here we have something called as the assumptions we have to take, right? So we have to take the assumption at the output terminal. So why we need to take the assumption value means, because by any chance I cannot able to find out the output if I don't know second input terminal value. So what are the assumption you can take? There are two outputs, right? The first output is Qn, another one is Qn bar. It means that if you are taking this assumption is 1, this way should be 0. Or one more possibility, what is there? Qn bar means if you are taking this value is 0, this always should be complemented, right? This should be 1. Ante if you are taking single input terminal, the either the assumption may be 0 or 1. The opposite value for this Qn is 1 0, right? So let it be, for example, we will pass this value. If you are taking this also, you will be getting the same output only. You try it, you will find the same output only. So in this case what I am going to take, I am going to take Qn equal to 1, Qn bar equal to 0. It means that 1 0, right? So after passing the value, right, so again we need to find out the final output. This is nothing but the initial output value. We need to find out the final output value. After deciding the final output value, we need to mention into the truth table. Now see that here we have the again condition. So what is the assumption value? 1, right? What is the assumption value? 0, right? After passing this value, right? So after this passing value into this circuit, this 0 into this circuit, we are going to find out the next level output, right? So how that next level output is depends, based on that we are going to mention into the truth table. Suppose for example, here what is the assumption value? 1, right? So after passing into the circuit, next level value also if you are getting the 1, it means same value, then it is called as the no change state, right? Suppose for example, if you are giving value equal to 1, after passing the circuit you are getting the next level output equal to 0. It means that toggle condition. Later on we will see what is the meaning of toggle condition. So as of now you remember that if you are giving the input value equal to 0, after passing the input output value also, next time output value equal to same value means it is called as the no change condition, right? Remember that one. Now what is the value we have taken? 1 0, right? So this value 1 0. Now how this value will go? The 1 will go to here, right? Because this is the feedback path, right? So now value is 1. So what about this 0, right? This 0 will go to here, right? This 0. Now we know the two input terminal values, right? So then we can decide the what is the output of the NAND gate, right? So 1 0 means what is the output value? This is the previous output, forget it. So 1 0 means what is the output value? 1, right? So next again 1 1 means what is the output value as per the truth table? 0, right? It means that assumption value equal to the final value. If assumption value equal to final value means, then it is called as the no change condition. No change condition means whatever the output will be generated previously, the same output we are going to copy it into the next level also. It means that this is called as the no change. This is what we called as the no change condition, right? So this is one possibility. Again, if you take something like this, you take Qn equal to 0, Qn bar equal to 1, the same value will pass to here, you will be finding the this value only, same value, same value. If you consider this condition also, this is what we called as the no change operation, right? So this is what the completer operation of the RS latch design by using of the NAND gate. Then one more important point to remember is that, right, if you follow the textbooks, you will be having the something like S bar R bar latch, right? So we can write in terms of the RS latch also. Y means S bar means S means set, right? S means set, right? Set means 1, right? So 1 bar means what? 1 bar means 0, right? Reset means what? 0, right? Right, reset means 0, right? So S bar will be equal to R. What is the meaning of 1 bar equal to 0? It means 0 equal to 0, right? Either we can write the S bar R bar latch, or we can write the RS latch. But instead of taking the S bar R bar latch, if you are taking the input SR, this is completely wrong, right? So S bar R bar R, we can take the RS. Input should be R, next input should be S. Don't try to take the for latch SR, right? So always try to take the R as well as the S, because it is the S bar, R bar is the basic operation of the latch, right? So I hope you understand. The main important logic to be remember here is that this table, then here for one condition, this condition. So how do we make the assumptions? After making the assumption, based on the next level output, we are going to decide, right? So if you understand this one, you can able to design any kind of the sequential logic circuit. It may be flip-flops, it may be SR latch, right? So RS latch by using of the NAND gate, NAR gate. So then flip-flop, SRJK, TD, flip-flop, master slave. Just to remember this logic, the same logic will be applied to the all other concept also, right? Thank you very much.